So here's what I'm going to do. We have a process to review today that I want you to not only be able to do, but to understand why we're doing what we're doing. So all of those that are on the front, okay. I want each person to pick one of those and multiply it out. But of course, I'll tell you what. I'll just assign. Okay. You're going to do this one. I want you to multiply that out, and you're going to write your answer up here. Okay? I want you to multiply it out, come up with the trinomial, and then, hold on. I forgot I was recording. Okay, please come up here, grab a pen. You can grab whatever color pen you want, I don't care. And write your answer, your trinomial. So it should be like x squared plus 2x plus 1 or whatever the case may be. Everybody. Some of the smart people wait till the line goes down. Have you flown on flights before and stuff? And then I hate it when you drive up, as soon as the plane starts, or as soon as the plane stops, everybody gets up out of their seat and stands up. I'm like, so 5 years when the time comes, right? Did you do yours? Oh, okay, you're just waiting still. No, you trying to factor it again? Why? I don't know. Mix. Excuse me, sir. I'm sorry. What's the shirt? I gotta see the shirt. Okay.
Where's Shane right here?
Oh, it's Friday. Thank you, sir. Okay. So what we have here is very similar to like 9 squared is 36 and all this good stuff. Okay? But these are always called perfect square trinomials. Okay? So what we're going to do is before we do this process today, we're going to look for a pattern in these. Okay? And I guess you guys have done this before. I just like to ground this in theory rather than just say, let's do this. Perfect. Okay? So what do you notice? Well, let's go like this. How do these two relate every time? What are they?
You just add the number
Twice. Okay? So all of those are twice. Right? Okay? And then, how do we get the 9? Well, multiply it by itself. So this is twice, and this is squared. This is twice, that is squared. This is twice, that is squared. Twice, squared, twice, squared. So all of these are very important. Like I said, those are called perfect square trinomials, and I can rewrite them like that. Okay? So how is this going to help us? Get your packet out. Okay? First thing, I want to, you don't have to flip to this, but I want to show you. We are using this process today. I don't know about you guys, but this problem right here, I thought was really easy. You square root both sides and add 8. Right here, you square root both sides and, subtract 8. Here, I square root both sides, add 4. Those are easy. So when we are solving some things, it's kind of nice to have it in this form. So the process we're reviewing today is completing the square. Okay? I'm going to show you the way I do it, and then I'm interested to see how Mrs. Gunther did it. So here's how I'm going to do this. If I look at this, is this currently a perfect square trinomial like all the ones you just wrote down? No, it's not right. What's not right about it? That 20 is not right. So that 20, I'm going to move it over to the other side. Okay? What would this have to be a perfect square trinomial? 16, where do you get the 16 from? Well, if we take a look at this, like say on this one, 12, this is half, and then we square it, we got 36. Look at the 8x, we took half of it and get 16. Look at the 14, we take half of it and get 49. Here we take half of this and square it and get 100. So in this case, what I like to do is I'm going to do this. I'm going to put 3 answer blanks that I got to fill in all 3 of these. Okay? And here's what I like to do. X plus half of 8. 4. 4 squared. 16. I'm going to add to the left side. To be fair, I got to add it to the right side. So these two things right here, how do they compare to one another? How do these two things compare to one another? They're the same. One's just written differently than the other. So again, here's what I like to do. Half of 8 is 4. Square it, and I got 16. And to be fair, I'm going to add both sides. Okay? So now what we're going to do is I'm going to square root this side. Square root this side. I get x plus 4 equals, what's square root of negative 4? 2i. And now to finish solving, so x equals negative 4 plus or minus 2i. We'll probably do, we'll do a couple more. But I'm going to do this on, I don't know, I'm kind of running out of room, but that's all right. I'll figure it out. So this 1 is not right, so what should I do with it? Subtract it. So I'm going to go x squared plus 6x equals negative 1. And again, I'm going to go 3 different answer blanks. Okay. So down here, this is where you remember, okay, My 6 comes from a couple 3x's, so this is going to be plus 3. So then what do I have to add to both sides?
3.
Not 3. 9, because x plus 3 squared is x squared plus 6x plus 9. Bless you. So then I get 8. Let's continue simplifying. Honestly, from here, I think if you're good, you can just do both steps in one. I'm going to subtract 3, and then my square root of 8. Okay, why? Because square root of 8 is 2 square roots of 2. I'll have the plus or minus, and then I'm going to subtract 3. Go ahead and try this next one. Is this similar to the way you've done it before? Pretty similar? Okay. Because there is another way to do it. Good. Move your 10 over. 10, we don't like you. Get over there. Half, square it. Take half, square it. I feel like I'm a little bit too. Okay. Half of negative 6 is negative 3. So what should I add to both sides? What should I add to both sides? 9. And the reason why I had you multiply those out is so you can see the pattern that's always involved with perfect square trinomials. Half of this linear term is 3. Square that, I get 9. Okay. What are we forced to do? 30. Just got those. Okay. I'm not going to take the time today, but the quadratic formula. You guys remember the quadratic formula, right? Okay. Negative b plus minus square root of b squared minus 4ac all over 2a. That comes from completing the square. Mathematicians got sick of this method. They did. They're like, honestly, when I've got a number out front here, or when this is odd, this method is not fun. Okay? So they said, I've got to find a better, faster way. So they did it in terms of A, B, and C, and they just came up with this formula. Negative b plus square root of b squared minus 4ac all over 2a. So let's do a couple examples, and then we'll go from there. First thing, this one here. What's my A? 3. What's my B? Come on. Negative 5. What's my C? 3. Good. Okay. So I'm going to go negative B, the opposite of B, which is 5, plus or minus the square root of B squared. I don't mind if you do the B squared in your head, because that part's easy. But this next part, write it out, because there's a common mistake. The common mistake comes from if A is negative or B or C is negative, then you would forget to cancel them. So here I got 5 plus or minus square root of, let's see, 25 minus, 9, 36. So 25 minus 36 is negative 11 over 6. And I'm not going to leave it that way. So let's go 5, 6 plus or minus square root of 11 sixths I. Where does that come from? I'm just cutting up the first part with no i's, and the next part, the part with i's. Do you guys agree with that? Did I get it right? I believe so. 12, 3, 40. No, this is not right. Yeah, it is. 12, 3, 36. Yep. Okay. Any ideas on the next one? Do you want to plug in 1/2 and 3/4, all that stuff? So what should we do to make our lives a lot easier? Could go decimals, multiply by. Yeah, I'm going to multiply by 4, just because, fractions, we all agree. Fractions, we're not as comfortable with fractions. Fractions will increase the number of mistakes we make. So I can multiply everything by the least common denominator, and I get 2x squared plus 3x minus 4 equals 0. Killing fractions. We're just multiplying everything by the least common multiple, technically. So go for it. Do quadratic formula from there. Scared me. How was your trip? Good. Was this a JAG trip? Is that what it? Or no? Next week's a JAG trip.
Oh, I might be I might leave a little early on Monday because that's a Thanksgiving.
Okay. Okay, wait until just a couple more people get done with it. Nate, would you get underneath your square root? Did you get 41? Okay. So here we go. There's my work. This is a great example of if you don't write this out, you might make a common mistake. If I write this out and I see that after that these two things will cancel, then I'm not going to make that mistake as often. So again, negative 3 plus or minus the square root of 41 all over 4. And in this case, just leave it. As long as there's no i's, just leave it. Okay. Okay. This number right here is incredibly important. This one, since that was positive, it has real roots. And this, since it's negative, it has imaginary roots. So this is what's called the discriminant. Because it's like, to discriminate is to think you know something by looking at it. Okay, if I know something by looking at it, they're calling it, this is the discriminant. This one, 41, it's positive, so I get 2 real roots. The discriminant here is negative, so then I get 2 complex roots that are not real. Okay? And then, if it's 0, I get 1 double root, technically. And here, I'm going to add something here. If it's a perfect square, it will factor. Okay? That's something that is kind of handy every once in a while. If you're trying to factor something that just doesn't want to factor, check your discriminant. Okay? If your discriminant's 25, yep, it'll factor. Your discriminant's 21, nope, it won't factor. So here we go. Let's go like this. Football players. Find the discriminant on that one. Guys that are not football players, find the discriminant on this one. Ladies who are not football players, find the discriminant on the last one. So find your discriminants. So it's just b squared minus 4ac, not the square root. B squared minus 4ac.